Hi guys, welcome to my channel. So today we are going to discuss about a mind-bending question, at least for me, that does information have weight? I'm talking about the data in your phone or your laptop. Does filling it up actually make them heavier? Do they have a physical weight? Let's find out. For a long time, information was just seen as zeros and ones, a mathematical concept. But then, scientists got a radical idea. Information is physical. This means information isn't just an idea. It has tangible presence and interacts with physical world, even possessing an energy equivalent.
So, how does abstract information become physical? Well, whether it's a hard drive or an SSD, bits are always encoded in physical systems. In hard drives, information is stored by aligning tiny magnetic domains within materials like iron or nickel. A 0 might be one orientation, a 1 another. For SSDs or solid state drives, it's all about electrical charges, the presence or absence of charge in a memory cell. The key is storing information always involves inducing a physical change in the storage medium. And here's where energy comes in. Switching these physical states, flipping a magnetic domain, or moving electrons requires an energy input. This energy is often dissipated as heat. This is one of the reasons why our pen drives or hard drives get hotter when we use them. This is called Launder's principle. Launder's principle states that erasing just one bit of information has a thermodynamic energy cost, and this can be defined as Boltzmann constant times temperature times log 2, and this can also be simply written as the following, and this is the energy that is dissipated into the environment as heat.
This shows a fundamental link between information and thermodynamics. This means that even to create information, a work has to be done. There is an energy cost. Because, as we all know, to modify a physical system, there has to be an energy input. So, this means information does not come out of thin air. Now, let's bring in the big guns. Albert Einstein's famous equation E equals to mc squared. Everyone has heard of it, and we know atom bombs are made out of it. But what does this actually mean? It implies that a tiny amount of mass can generate a huge amount of energy, and vice versa. Now, when we combine Landauer's principle and E equals to mc square, we understand that information, which has an energy equivalence, also has a mass equivalence. So, from this principle, we can actually determine the weight of a single bit.
Let's take E equals to mc square and use Launder's principle in this. We get the following equation, and when we substitute the constant values, we can actually calculate mass of the bit, and this turns out to be 3.19 into 10 to the power minus 38 kilograms, and for reference, mass of an electron is 9.12 into 10 to the power minus 31 kilograms. So mass of a bit is 28.5 million times smaller than mass of an electron.
So, it's pretty clear now. We cannot measure such fractional changes. So, what about our original question? So, does a full hard drive and an empty one have a weight difference? Well, I think you already got your answer. So, in your everyday practical uses, you might not find a difference at all. Theoretically, yes, but practical day to day use, definitely not. We will never be able to, okay, I won't say never, but we will not be able to find the difference at all. Okay. So, our gadgets don't get any heavier, but the theoretical implications are huge. Information is a physical entity. It has an energy equivalence, and that means it has a theoretical mass, which actually takes us to a fundamental concept that information, mass, and energy are interlinked. While I was researching this topic, I had a realization. Our brains store information. They constantly record memories. So, do they get heavier day by day? how can we link these two topics? Maybe it's a topic for another video. See you.